Hi there, this video is Math 813. 813, so I would like you to get a couple of things. You need your math workbook, you need your math homework 813, you need a smile on your face because this actually is a cool lesson. This is one of the coolest things. I say that a lot, but I love 5th grade math. And I will tell you this also, this is something that you will use in 6th grade. I happen to know that because I taught 6th grade last year, that this is something that you'll take on with you. So it's kind of cool. I don't remember learning it when I was younger, so which could have been for a couple of reasons. Either I just don't remember because I'm getting old, or I don't remember because I was talking too much to my friends in class, or they didn't teach it like this. It could be any one of those, and I'm not sure which one. Anyway, so this lesson is about line plots. Line plots. And we're working with fractions again today with our line plots, but it's nothing difficult. It's all stuff with fractions that you've already done. Now we're just putting in a line plot with that. I'm going to try to make this video really quick because I know that you have a Khan Academy video that you're also watching to help really solidify this whole concept. But I do want to talk for a minute about our line plots. I'm scooting my chair back. I'm getting my trusty whiteboard handy. A line plot is a really convenient way to look at information, data that we're gathering about something. So just so that we can really think about this in regards to our class, let's just say we wanted to take data for heights of people in our class, okay? So I'm going to say that everyone in our class is really between, 4 feet and 5 feet. Now I know there's some of you that are taller than that, but this is just for this line plot today. So here's 4 feet, and here's 5 feet, and so this would be 4.5 feet. This would be 4.25 feet. Hope you can read my writing here today. And this would be 4.75 feet. You know, there are different ways that we can list the bottom, but let's just say that we were checking our class for feet today. You could, on your line plots, you could do anything that you wanted. You could do centimeters, you could do meters, whatever, but for our class today, this is what we're doing. Okay. So now, remember, I do not know anybody's real height. So if I use your name and I put it on here, I'm just throwing things out. It's not meant to offend anyone if I put you here and you're taller than that. Don't be mad because I made you look short. That's not my intent. We're just trying to get some information up here. And I'm trying to get people to use a real world experience, which would be our class and the people in our class, right? Okay, so let's say, we might have some shorter people in our class. And I'm just going to make up names. So say we have in our class a shorter girl named Jennifer. She is 4 feet. So this dot represents Jennifer. Okay. I also have another person that is about the same height as Jennifer. She's not 4.25 feet. She is about 4 feet. So this is another person in our class that's about that same height. So each dot represents a person. So we've got a boy here named John, and he is 4.25 feet, right? And then I've got Bill is 4.5 feet, and Sheila is 4.5 feet, and Ricardo is 4.5 feet. Okay, then moving up, I've got Jeremy, who is 4.75 feet, and Blakelyn is 4.75 feet. Oh my gosh, and we've got Timothy and Roger and Shelly. Though they are all about 4 3/4 feet. Can you believe that? We got a lot of kids that are that same height. And then over here that's 5 feet tall, we've got Carl and Rebecca. Okay? Now each dot represents a person, and then their height is listed at the bottom. So it's easy to take a look at this line plot right here and say, okay, well, what is the height that most people are at? Oh, well, gosh, most people, 1, 2, 3, 4, 5 people, and it's easy to tell because I know with my eyes that there are more dots over this one. So I know that most people, or the height that is the most, I can't say popular, the height that has the most students at that height is 4 3/4 feet. Okay. The height that the least amount of students are at right now is 4 1/4 feet. Okay. So this is like if this was our class, and remember that each dot represents one person, and we can look at the height differences. Okay, so now that we've kind of got a little basis on that, we're going to come back to our board here in just a minute. But I'd like you to go in your workbooks to page 345, 345. Oh yeah, I'm going to use this. We're going to look at some other samples here. It's talking about soil samples, okay? So let's take a look. We're going to just read from the top. Soil samples were taken for 10 days for a biology project. The frequency table, so this is the table at the right-hand side. It says weights and number of samples. This is our table. The frequency table below shows the number of times the various weights for the samples occurred. So instead of doing heights on their line plot, they're going to actually show weights. Can you guys see me okay? It's more important to see the board anyway, I guess, right? You can organize data on a line plot to make the data easier to analyze. Okay, so we want to be able to see really well where those samples were, what they weighed. And the way to do that is to put it on our line plot. So we're going to I'm going to recreate this line plot as fast as I can. Okay, so we've got 0. We've got 1/8, 1/4, which is the same as 2/8, right? I want to make sure that you realize how we're going here. This is 3/8. Then we've got 1/2, which is 4/8. And then we've got 5/8 and 3/4, which is the same as 6/8, right? Okay, so they've already got a couple dots on there, and they've got them from the table. So if we look over here, so the sample weight is 1/8. So I'm looking at my table right here at 1/8. There are one sample that weighs 1/8 of a pound. So they've got one sample, so that's one dot that goes over the 1/8. Then for the next one in our table, weighing 1/4 of a pound or 1/4 of a pound, they have two samples. So I'm going to put 2, like they've got in their example, right there. That's all they have listed right now. Number 1 says the line plot has been filled in for sample weights of 1/8 and 1/4 pound. Complete the rest of the line plot. So I challenge you to complete the rest on your own. You can pause the video, or you can do it on your own and then check back with the video, because I'm going to actually plot them on there. If you're a little bit lost and you're not really sure, then stick with me and we'll plot them on together. So the next line on our table says 3/8, that's right here on our chart, right here, 3/8. And there were 3 samples that were weighing 3/8 of a pound. So I'm going to put 1, 2, 3 samples right there. Okay. The next line is 1/2 pound. There's only 2 samples that weigh 1/2 pound. So I'm going to go 1, 2. And then our last one is 5/8 of a pound. And there are 2 samples. So 5/8 is on our chart right here. 2 samples. I did my 2 dots. Okay. Now, number 2. So, well, first, let's just analyze this a little bit. Which one on here shows? Let's see. What weight? How do I ask this question? I feel really weird right now. I can't think how to ask this question. Which weight occurs the most? The 3/8 of a pound, right? Because 3 of the samples weigh 3/8, but 1/4 of a pound only has 2 samples, and 1/2 of a pound has 2 samples. 5/8 of a pound has 2 samples. So the one that occurs the most is the 3/8, because 3 of the samples weigh that amount. Number 2 says, based on these samples, which sample weight is least likely to occur? So let's think about that. Coming to the other side here. What it means is, based on the data that we have, which one occurs the least amount of times? And that is the 1/8 of a pound. 1/8 of the pound. So that's what we're putting for number 2. There we go. Okay. Number 3, based on these samples, which sample weight is most likely to occur? And that's what we were talking about just a second ago. Which one happens the most? Or which one has the most dots? And it's the 3/8, right? Because this one has 3, where the others either only have 1 or 2. This one has 3. Okay, so that one we are putting the 3/8. That's for number 3. 3 is 3/8, right? Just like this. Okay, number 4, what is the total weight of the samples weighing 3/8 of a pound? What is the total weight of the samples weighing 3/8 of a pound? How many samples weigh 3/8? 3, right? 1, 2, 3. And we know they each weigh 3/8 because that's what it's listed. So in order to do this, we would do 3/8 plus 3/8 plus 3/8. Okay, because we have 3 samples, 1, 2, 3, that each weigh 3/8 of a pound. And if we want to find out what they weigh together, the total weight, we're going to add them all up. We can do that right now because they all have the same denominator, so we're good to go. So we've got 3 plus 3 is 6, plus 3 is 9. Keep that same denominator, 9/8 of a pound. We don't want to leave it as an improper fraction. Let's turn it into a mixed number. So 8 goes into 9 one time with 1 left over, and we keep the same denominator. So 1 1/8 of a pound. Don't forget that label. 1 1/8 of a pound. That's what we're looking at for number 4. Number 5, this one gets a little bit more tricky. It says, if the total weight of the samples were redistributed evenly among the 10 samples, what would each sample weigh? If they were divided evenly, when I think of that, I actually am thinking of an average weight, right? If we divided them evenly, I wish I could take your hands because I want to know how you would solve this. And unfortunately, since our classrooms are different, we can't do that. So I'll tell you how I would solve it. I would multiply each weight by the number of times that it occurs, like 1/4 I would times by 2, right? 3/8 I would times by 3. And then I would add all those together. Then I would divide by the number of samples that we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I would divide by 10, and that would give me basically an average. So if we did that, and I'm actually not going to take the time right now. I'm going to see what we have on our homework. If we have one like that on our homework, we'll do it together. We'll talk about it. But if we did that, they would average out to be about 2/5 of a pound would be the average, or 4/10. 4/10, 2/5, like that. Okay, we'll work on that a little bit more. We'll check the homework. Okay, but I promised to do a short video, right? Okay, so I think you're understanding this part. It's hard to know because you're not right in front of my face and I can't say, give me a thumbs up or a thumbs down, right? So if you have questions, you'll have to put it in the comment and we can talk about it in a Zoom class, or I can try to explain it that through your comment. If we are looking at, in fact, turn your page to 346. Let's look at number 6 together. It says, for 10 days, Mario measured the amount of food that his cat, Toby, ate each day. The amounts he recorded are shown in the table at the right. Now, this could be a real-world problem because every once in a while, we have pets that get sick. Now, some of you might not have pets, and that's understandable. But maybe in the future you have a child, and you need to measure how much they eat because the doctor needs to know. Maybe they're sick with something, so we've got to measure. So this is like a real-world problem. It could happen. Okay, so we have our line plot right here for number 6. We have the graph or the table at the right, and let's go ahead and plot those. If you want to try before, and then you can just check it with me, go ahead and pause this video, put them on there, and then check back, and we'll see. If you need a little more guidance, then stay with me and keep it on play. Okay, so amounts Toby ate each day. I'm going to label my chart first. So I'm going to say this is 1/4 of a cup. And the way I know is because it's listed right here on the side. I've got 1/4 of a cup, 3/8 of a cup, 1/2 of a cup, 5/8 of a cup. And just so we know, like that's 1/2 is equal to 4/8, counting by eighths. This would be 2/8. Okay. Just because I don't want anyone to get 3/4 is the same as 6/8. Okay, so we're all together with our fractions. Okay. All right, so we've got tally marks in our table. These are tally marks. So this is not the number 11, they're tally marks. Like when we do our table points. Tally marks like that, okay? Okay, so let's look at our tally marks here. There were 2 days that Toby, the cat, ate 1/4 of a cup of food. 2 days, like that. Okay, mark it. Now you need to label your line plot just like I did. You don't have to include those fractions on the bottom. I just want to make sure everybody is with me with our fractions. Okay, and then I need you to label your dots. If you need a pause so you can catch up, pause anytime and then rejoin. Okay, There was only one day that Toby the cat ate 3/8 of a cup, so I'm going to put a dot there, for a half a cup. There were 3 days that Toby ate a half a cup. Good, Toby. Okay. There were 3 days that Toby ate 5/8 of a cup. Right? Here's 5/8. 3 days. 1, 2, 3. Okay. And then there was one day that Toby was really hungry and he ate 3/4 of a cup. Now it tells us at the top of our table that this was for 10 days. But we also could have known by counting, right? So 2 days, 1, 2, he ate 1/4 of a cup. 1 day, he ate 3/8 of a cup. So if I add all these dots up, that tells me how many days. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And it tells us too that that was for 10 days, so that makes sense. Okie dokie. 6A says, what is the total amount of food Toby ate over the 10 days? Explain how you got your answer. Okay. Well, in order for us to do that, we would have to add all these up, right? Well, since there were 2 days that Toby the cat ate 1/4 of a cup, we would need to times 1/4. Can you see that low? Barely, huh? By 2. That looks like a plus sign. I gotta write better here. Times 2 over 1, right? There's 2 for the fourth, so I need to do 1/4 times 2. Gotta make it be a fraction, so it's gonna be 2 over 1. 1 times 2 is 2. 4 times 1 is 4. Okay. I'm just going to leave it like that right now because I'm not exactly sure what my common denominator is going to be. So I'll list it up here that this is 2/4. So these two together is 2/4. Okay. Now, I just have 1 3/8, so I can leave that. So we're going to leave 1 3/8. Okay. Now I've got a half times 1, 2, 3, right? There were 3 days that he ate a half a cup. So I'm going to do 1/2 times 3, 3 over 1, because I'm in fractions. Okay, 1 times 3 is 3. 2 times 1 is 2. So this is going to be 3/2. Okay. Then there were 3 days that the cat ate 5/8. So I've got to do 5/8 times 3. 5 times 3 is 15. 8 times 1 is 8. Okay, so I'm going to do 15/8. And I've got to do a common denominator in the end, so we'll figure that part out later. But we're going to be adding all of these up at the end. All right, then we've got 1 day that Toby the cat had 3/4, so I can leave that at 3/4. And you know what, maybe it would have been better if I used these other fractions that I put on there so I had it in the right denominator. You could do that next time. I probably should have thought ahead and done that. Okay, we are going to add all of these up, but in order to do that, we have to have a common denominator, right? Here I've got a 4, a 2, an 8. What could be my common denominator? Can you all see these? I hope you can see them. What could be my common denominator between all of those? 8, right? Yeah. All of those numbers go into 8. Okay. Can I just show you another way that we could show the equation? I really should include that I'm not just adding them like this, but it would have looked like 2 times 1/4 plus 3/8, or 1 times 3/8. Let's put that so you understand. Plus 1 times 3/8 plus 3 times a half. Oops, I gotta do that better. Plus 3 times 5/8 plus 3/4, or 1 times 3/4. Right, this is how basically I am setting up my equation. That's what I was doing down here, and then this is the total. Okay, so 2 times 1/4 is 2/4. 1 times 3 is 3/8. 3 times a half is 3/2. 3 times 5/8 is 15/8. And then we've got 1 times 3/4, which is 3/4 right here. Should have written that a little bit better so you can kind of see what our equation was going to be. Okay, so now that we've got that, I'm just going to let that go. And we'll go back to adding these all up. Now, yes, we've got to have a common denominator, and 8's going to be it. So I'm going to do this kind of quick. We've gone over this part before on finding common denominators. You really should be there. So I'm going to keep the ones that are already at 8. I'm going to add my plus signs in here. We'll get going. Okay. I need to turn this one into an equal fraction with a denominator of 8. To get from 4 to 8, we times by 2, right? So I would need to do the same to this numerator, and that would give me my denominator of 8, okay? 4 times 2 is 8, so for our numerator, 2 times 2 is 4, okay? All right, we've got to change this one to an 8. 2 times 4 is 8, so 3 times 4 is 12, okay? Last one over here, 4 times 2 is 8, so 3 times 2 is 6. There we go. Now we can add all these up. We know our denominator is 8, so I can write that over here on the side. Let's say, we'll go through it, 4 plus 3 is 7. 7 plus 12 is 19. 19 plus 15 is 34. Am I right? Plus 6 is 40. Okay. Let's try that. I'm going to try another way. Just make sure I'm right. 3 plus 12 is 15, and I know that 15 plus 15 is 30. 4 plus 6 is 10. 30 plus 10 is 40. We should be good. Okay, perfect. Now, we can't leave our fraction like that. For one, it's improper. So we've got to reduce it. But I know that 8 goes into 40. 40 divided by 8. Remember, this fraction bar can mean divide. So 40 divided by 8 is 5. So our answer is 5. We've got to remember our label cups. So the total amount of food that cute little fat cat Toby ate was 5 cups of food. That's how we can add up all of the information in our line plot and find a total. Okay? Dun, 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 dun. Okay, let's look at our homework. This is going a little bit longer than I planned. I think you'll actually be fine, especially if you watch the Khan Academy video as well. And there's only 2 problems. Now, yes, there are subsets, A, B, C, and A and B, which is basically 5 things, 5 problems. I want you to do all. 8, 13, all. You've got this. You're amazing. You'll be fine. And if you need to rewatch the video or rewind or anything, you definitely can. Have a wonderful day. You're amazing. See you.